Hello everyone, and thank you for joining me. We are going to talk about SOLIDWORKS 2018's latest enhancement to flow simulation. My name is Arvind Krishnan and I work out of Go Engineers Dallas office. And today we are going to talk about free surface and how it lets us simulate the flow with a freely moving interface between two immiscible fluids. Think air and water in a cylinder and how it interacts with each other. So to do that, the first thing we're going to talk about is prepping your model for such a simulation. Now I know there's 100 different ways to do this, but you need to define the internal volume where you have a region with one fluid as compared to another. To do that, the way I typically like to do it is to define the entire inner fluid region. Flow simulation has a capability to do that, where you can go to check geometry on the top, make sure everything is included, and then click on this create fluid body on the bottom left and then hit check. So first off, if your internal volume is closed, it's going to make sure that it tells you that it's a success, and then it is going to create a fluid sub body of the entire volume on the inside of that cylinder. You can then use that cylinder to do a surface cut to define what region is air and what region is water in our case. So I've gone ahead and done that. Here is my model with the fluid volume on the inside. Let's go ahead and evaluate it first. I'm going to hide the outside and you see the inside fluid volume where I've done a surface cut to create two different solid bodies. The top part represents air and the bottom represents water. And we're going to define that inside flow simulation. So let me go ahead and unhide the outside boundary again, and we're going to use the wizard to set up the analysis. Let's call this free surface, assign some units, and finally we get to the most important page of the wizard, which is the physics. Whenever you have a free surface, it's not a steady state condition because it's constantly changing based on the conditions that you have. And hence, it's always going to be a time-dependent analysis. We're going to run the study for 10 seconds and collect results every 0.2 seconds. We also want to make sure gravity is checked. This way, the density changes is going to affect the movement of the fluids because of buoyancy effects. I'm going to reverse the direction of gravity. That way, you have the water having to go out and air coming in from that bottom hole. And finally, we have free surface that we're going to check as well. So because of this, we can go ahead and include air and water. So I've already set up an analysis. Let's go ahead and pull that up. Once again, the bottom end is considered open. Think of this as you having a cylinder with water filled about 80%, and then you open the bottom, and what happens as soon as you open the bottom. So this bottom is exposed to air on the outside and you're going to see the water falling out. So here's my environmental boundary condition for atmospheric pressure, and then here's my two initial conditions with the two solids that I have, where this one is air and the next one is going to be the definition of water. I've set some goals up for the volume fractions and the velocity. Now I'm going to go ahead and load up some results. If you watched last year's video, you would have seen the new transient explorer feature. And now we're going to look at a cut plot. And then we can go ahead and hit play. As you go across from time equals 0 to time equals 10 seconds, you can see how more and more air comes in from the bottom because of the density differences. And you can also see the interaction with that free surface between the air and the water. Just truly beautiful. This is an enhancement for 2018 SOLIDWORKS Flow Simulation. If you have any questions, feel free to contact us at Go Engineer. Once again, this is Arvind Krishnan, and I hope you liked this video. Thank you. Goodbye.